In this video, we are going to present a case study on applications of microprocessor. I am Tailashri and my teammates are Navina, Architashri, Pravin Kumar and Kartikeyan.
I'm going to share about microprocessor. A microprocessor is a computer processor where the data processing logic and control is included on the single integrated circuits or a small number of ICs. The microprocessor contains the arithmetic, logic and control circuitry required to perform the function of a computer's processing unit, which is denoted as CPU.
Now, let me explain the block diagram and working of microprocessor. The microprocessor follows a sequence: fetch, decode, and then execute. Initially, the instructions are stored in the memory in a sequential order. The microprocessor fetches those instructions from the memory, then decodes it and executes those instructions till stop instruction is reached. Later, it sends the result in binary to the output port. Between these processes, the register stores the temporary data and ALU performs the computing functions. So the block diagram of a basic microcomputer: input device, microprocessor, it to output device and stores it in memory. Next, terms in microprocessor. Instruction set. It is the set of instructions that the microprocessor can understand. Bandwidth. It is the number of bits processed in a single instruction. Clock speed. It determines the number of operations per second the processor can perform. It is expressed in megahertz or gigahertz. It is also known as clock rate. The next, word length. It depends upon the width of the internal data bus, registers, ALU, etc. An 8-bit microprocessor can process 8-bit data at a time. The word length ranges from 4 bits to 64 bits depending upon the type of the microcomputer. Data types. The microprocessor has multiple data formats like binary, BCD, ASCII, signed and unsigned numbers. These are the important terms used in microprocessor.
Applications. Personal computers. Microprocessors are the heart of the personal computers. They control the operations of the computer and manage the execution of software programs. Embedded systems. Microprocessors are used in a variety of embedded systems such as automotive electronics, consumer electronics, medical devices, and industrial control systems. They perform specific functions such as monitoring and controlling sensors, actuating motors and actuators, and performing signal processing tasks. Communication system. Microprocessors are used in communication systems such as modems, routers, switches, and wireless access points. They manage the flow of data between devices and networks. Gaming consoles. Microprocessors are used in the gaming consoles to control the graphics, sound, and user interface.
The next application is mobile devices. Microprocessors are used in mobile devices such as smartphones and tablets to manage the operating system, user interface, and applications. Robotics. Microprocessors are used in robotics to control the movement, sensing, and communication of robots. And automation. Microprocessors are used in automation systems such as manufacturing and assembly lines to control the flow of materials and manage the production process.
Applications, instrumentations. Microprocessors are used in scientific instruments and laboratory equipment to control the operation, analyze data, and communicate results. Security systems. Microprocessors are used in security systems such as alarms and access control systems to monitor and control access to buildings and properties. Entertainment systems. Microprocessors are used in entertainment systems such as home theaters and audio systems to manage the playback of media and control the user interface.
Thank you.